Hi, this is Dr. Baby Shalini, Associate Professor, Department of ECE, Rohini College of Engineering and Technology. In this video lecture, we are going to see about frequency compensation method used in amplifiers. So first let's see about amplifiers. So amplifiers are widely used to increase the strength of the signals. When feedback is applied, the amplifier can become unstable, especially at high frequencies. So to prevent this condition, frequency compensation is used to avoid this instability. So first let's see what is stability. Stability means the amplifier output remains controlled and does not oscillate. An unstable amplifier produces unwanted oscillations even without an input signal. So stability is an important requirement in amplifiers, especially in operational amplifier circuits. So next let's see the role of feedback in amplifiers. So negative feedback actually improves the gain accuracy and also the bandwidth. At higher frequencies, phase shift increases in the amplifier. This phase shift can convert negative feedback into positive feedback. So next let's see the cause of instability. So the internal capacitances and multiple gain stages cause phase shift in the frequency. When total phase shift reaches 180 degrees, oscillation may occur and this condition leads to instability in the amplifier. So for perfect operation of amplifier, we should avoid oscillations, but these oscillations are occurring due to phase shift. So to avoid this condition, we have to go for frequency compensation. So next let's see what is frequency compensation. Frequency compensation is a technique used to control the frequency response of an amplifier. It ensures that the amplifier remains stable over the required frequency range, and this is achieved by modifying the gain at higher frequencies. So the main idea is to reduce the gain at higher frequencies. This prevents the phase shift from causing oscillations. So a dominant pole is introduced to control the response. The performance of all the amplifiers are mathematically represented in terms of transfer function. So the transfer function has both numerator and denominator terms, and the denominator terms when equate to 0, they will give the poles of the system. So when we add some additional pole called as the dominant pole into the system response, we can provide frequency compensation. So next let's see what is a dominant pole. So a dominant pole is a low frequency pole added intentionally into the transfer function of amplifiers. It makes the gain decrease yearly with frequency, and this ensures stability before higher frequency poles take the effect. Next let's see the types of frequency compensation. The frequency compensation can be of two types. They are internal compensation and external compensation. Internal compensation is built inside the operational amplifiers, and external compensation uses additional components external to the amplifier such as capacitors. So let's first see what is internal frequency compensation. In internal frequency compensation method, a capacitor is connected inside the IC or operational amplifier. This capacitor creates a dominant pole, and such op-amps are stable for most applications. Next is external frequency compensation. External frequency compensation is used in high-speed or special applications. An external capacitor is connected by the designer in order to provide stability. It also provides flexibility in controlling the bandwidth. Next is advantages of frequency compensation. So first thing is the frequency compensation prevents oscillations in amplifiers, and it improves reliable operation of circuits, and it makes the amplifier behavior predictable. And next is the applications of frequency compensation methods. So frequency compensation is used in operational amplifiers, audio amplifiers, and control systems. It is essential in feedback amplifiers because feedback amplifiers are mostly suffered by instability. Next is it is widely used in communication and signal processing circuits. So finally let's come to the conclusion. So the frequency compensation is necessary to maintain amplifier stability. Also it controls gain and phase especially at higher frequencies. Thank you.